So chapter 3 is the last chapter we're supposed to be covering in marking period 1. And again, I strongly encourage you to make sure that you are taking your notes on this stuff and you are actually writing everything down that I have on my note sheets. And then going back and maybe watching my video so you can see me explain it, just because in this particular chapter, this is when proofs are going to take off. Every section, a new line is going to get added to the proof, so they are going to get longer. So the first section that we're going to cover is 3.2. It is called 3 ways to prove triangles are congruent, but I'm actually going to teach you a 4th way so that you have them all at once instead of separating them. So the first thing we want to go over is this new vocabulary word called included. Okay, so when something is included, or angle H is considered to be included, it is included by the sides GH and HJ. So ultimately what that means is it's in between. All right, or it's made up of those two sides. That is what included means. And if we had an included side would be between two angles. So when we talk about triangles being congruent, basically what that means is that all pairs of corresponding parts are congruent to each other. Again, when we talk about corresponding parts, we're talking about sides and angles. Now, with this chapter, not so much with what we've done in the past, but the order you write stuff in is going to matter. So if you look at these two triangles right here, triangle ABC and triangle DEF, according to the markings, you want to make sure the way that you're naming it goes in the proper order from one triangle to the other. They have to match up. So the markings are crucial. So if you see a congruent mark on A, then A has to match with D. So those need to be written in the same spot. No other angles are marked, but if you look at the sides, AB has 2 markings on it, and then DE also has 2 markings on it. So that means if we've already used A and D, the next letter that we should use should be B. And then, given that it's a triangle, process of elimination leaves us with that third letter, C and F, which has to come next. Now, that's not the only way of writing this triangle congruence. We could have written it, say, here's another version. I could have said BCA, triangle BCA, and then triangle BCA would then be congruent to EFD. There are other ways of writing it as well. These are just 2 instances. But the key is you just have to make sure that whatever order you choose for the first triangle, that the second triangle matches that. So let's take a little note here. So it says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So that's something just to keep in mind. There's no theorem for that yet. And to be honest, it's not necessarily something you're going to use right now. The focus of this section is now going to go over ways to prove triangles congruent. And again, there's 4 of them. So the first way is by something called side, 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 which we abbreviate with SSS. And it says postulate. What a postulate means, it's just a mini theorem, so it doesn't change anything. So what this theorem says, or postulate, it says if the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. So we have 2 triangles here. All 3 sides are marked, which means these 2 triangles would be congruent by side, 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 SSS. Therefore, it just comes down to you writing a proper statement in terms of a triangle congruent statement. So if we go G to H to F, looking at the markings, G to H has 1 mark. So whether you color code, whatever you got to do, the markings, those should be there to show congruence. This has 2 on it. And then the third side goes right here. So again, you have flexibility in terms of how you want to write it out. I went from G to H to F, which matched with P to Q to R. You could have also done G to F to H, and GFH would have then matched with P to R to Q. You could have done F to G. If you did H to F to G, that would get you Q to R to P, and so on. So again, there's many ways of writing it, but whatever you choose to write for the first one, that second one needs to match whatever you had there. All right, second one is side, angle, side, SAS. So what it says is if 2 sides and now the included angle, so included means in between. So the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So we have our included angle here, which is C. And then we have our two side lengths. So we have CB and DF. And then we have CA and DE. So I just chose to write BCA. Triangle BCA is congruent to FDE. Again, you also could have said triangle BAC is congruent to triangle FED. You could have said CAB is congruent to DEF. Again, there's lots of options that you could have written for a triangle congruent statement. The third type is angle side angle. So the side is in between the two angles, so that's ASA. That means that we have two angles and the included side of one triangle are congruent to two angles and the included side of another. Then the triangles are congruent. So again, the side is in between the two angles that are congruent. And then if you're opting, still put the congruent marks, but if you're choosing to do colors as an added thing, you certainly can do that. And again, the order I just chose was triangle HGB, which would match with NKP. But there's other ways of writing it. That's not the only way. All right, the fourth and final one is angle side. So the difference here is we still have two angles, but now the S is not between the two angles that we have, which means the side is now non-included, which means it is not between the two angles that we have. So it says if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another, then the triangles are congruent. So we have C says here is congruent to X. Then we have D and G. And then we have our side. Again, the side cannot be the one that's in between those two angles that we had congruent because we said it's non-included. So one version of a triangle congruent statement would be triangle CDM, which would match with XGT. But again, you have flexibility in terms of which one you want to write. Now, the reason I have this comment at the bottom, because we have 4 different ways here. Side, 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 angle, side, and angle, side. Lots of A's and lots of S's mixed up. Those are the only 4 that we have. So there is none for ASS. Or, to be honest, ass backwards, which is SSA. And as you're watching this, you might laugh, but I'm telling you, people make this mistake so much because they just assume that this is one of them. But the only 4 that we have are the 4 that we just wrote. Side, 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 angle, angle, and angle, side. There are no more than that for triangle congruences. All right, so let's try example number 1. So it says you're given the congruent angles and sides, and we want to name the additional congruent sides or angles that are needed to prove that the triangles are congruent by each postulate. All right, so the first one, we have 2 triangles, ABC and DEF. We have 2 sides marked. And for A, we want to prove it by side, 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 which means I need all sides accounted for. So what am I missing? I'm missing the third side. So if I mark them, I then need to go in a proper order. So if I'm going from A to C would have to match with D to F. If I shift colors here and go with green for B, if I now want to do side, angle, side, well, that's showing that the A is in between the 2 sides that are congruent. So then I would need the angle that is included between the 2 sides, which is angle B and angle E. Okay, now for proofs, again, you're going to have to use 3 letters, so it's good practice. So I'm going to call this ABC, which is congruent to angle DEF, instead of writing B and E. I want you to get in a good practice of using 3 letters for these. All right, next one. So we have our 2 triangles. For A, we want to prove it by side, angle, side. So if it's SAS, that means the angle had to fall between the 2 sides, which means I need another side over here on the other side of the angle. And then in the right order, GJ is congruent to OM. If I want to go the other way and go with angle, side, angle, that means the side is now in between the 2 angles. So I have 1 angle and a side, so I need another angle, which would get me down here because, again, the S has to be between the 2 angles that are congruent. So I'm going to use 3 letters again. So GHJ would then be congruent to angle OKM instead of just writing H and K. All right, last one of this type. So we have 2 triangles here. Now, we're talking about PWT and SVR. So what you may want to do is redraw it, to be honest, because it might be a little confusing given the way that it's presented. But I will tell you that you're going to definitely see a lot of things along these lines. So I'm just redrawing the two triangles that are being discussed in this particular problem, just so that we separate it a little bit. All right, so if we look here, we're saying, all right, well, I want to prove it by SAS. So that means my angle has to be between my two sides, which means this needs to be my second side. So T to W would then match with R to V. And if I'm doing ASA, that means